Robert Reed is a principal engineer at Intel. He's got a great ponytail. He's a really nice guy.
It's not going well.
So, you know, when you're in San Francisco, I mean, he's usually good for a free meal. No, I'm sorry. Ladies and gentlemen, Robert Reed, he's going to be talking about Lustre HSM in the cloud. Sorry about the free meal thing.
It's all right. Yeah. Good. See that? So, Lustre in the cloud. A couple of years ago, I was here and I talked about Lustre in the cloud and demonstrated or showed in some performance metrics that Lustre runs well in the cloud. It scales just as well as you'd expect, and it gets performance you expect, and sometimes even better than you'd expect in some cases. And since then, Amazon's released more instance types, enhanced networking, more features that makes Lustre run even better in the cloud, and getting a lot more interest in running Lustre in Amazon. And we got feedback from, and it's not just HPC, in fact, we got feedback from customers that it turns out SAS Grid runs really well on Lustre, and it's a great solution for running SAS Grid in AWS. And so what we're seeing, though, is that Lustre, in some cases, when it's still a scratch file system, for example, you use Lustre for your fast parallel file system as it's normally used, and it's a scratch, so you move data to somewhere else where it's more permanent, like the simple storage service in Amazon, S3. And when you take the tear down the compute system and delete those instances, you also tear down the file system. There's no reason to keep the file system around if you're not using it. It's expensive to keep it running all the time, and it's cheaper to store data in S3. So we need to have tools and new processes for managing data and pulling that outlives the file system it came from. And we create a new file system, import data back into the file system that you need to compute out of S3. So one approach to doing this is, I thought, well, let's explore using HSM for doing this. Lustre's got these new HSM features. It kind of supports some of the things we'd like to see, like this idea of an on-demand approach of fetching data when an application reads it. But on the downside, the existing tools for HSM don't support S3, and there's a few other challenges. And I'll note that most of the things in this slide are experimental or just ideas. There are a couple of things that have been implemented, but it's really just ideas and talking about some new things we can do. So the first challenge I really encountered was that using FIDs to identify files in the archive doesn't work well when you're going to import them into a different file system. Now the existing copy tool has the ability to rename files if you import, and that's fine unless that archive is being shared and imported into multiple file systems. Then that doesn't work. And also in S3 in particular, there's no rename operation. You have to copy the file, and that doesn't really make sense. And I don't want to have to use a database. I'd like to have the data fully contained in S3 if that's the archive format, or some other storage backend where it's on its own and it doesn't require a database to map IDs to names and so on. And so the takeaway here was that, though, if your data is going to be exported and outlive the file system it came from, don't use the FIDs to identify the files. You'll end up with duplicates, and that won't work. So how about generating a GUID for each file? Well, that's easy to generate. You can store it as an extended attribute with the file, so you don't need a database. It's just using the metadata as the database. And you could the GUID can be generated at various places, and some like object storage backends you'd write the object and it tells you what the identifier for that object is, and so you could store that instead of the GUID if you use a different kind of something other than S3. The disadvantage, though, is that when the file is deleted, since the mapping is stored in the extended attributes, that mapping is lost if the file is deleted. And one option I've heard suggested is we could have the extended attributes for HSM included in the changelog record or maybe in the HSM action. And another idea might be, in a similar way that we retain files that are open and then deleted, the inode is retained while the file is still open. If in a different implementation, but the idea here would be if a file is deleted but has an HSM flag set, like an archive flag or an exist flag, then retain the inode around someplace where the policy engine or copy tool could come around and see that and then clean up the back end based on the inode and clear the flag, and then the inode would be fully deleted. Just an idea for that. But then I realized, so we're using extended attributes to store the HSM identifier, an EA can be anything, so why not just a URL? So that's where we had a different idea. Instead of exporting data to S3, you could actually import data into Lustre that's already in S3. So the first thing we implemented actually was the idea of importing an existing bucket in S3, which is just basically a list of keys with associated data, import that directly into a Lustre file system, regenerate the POSIX namespace based on the keys, and then import the data as needed using a copy tool. So we implemented some tools to do that. There's an S3 import tool which scans the keys, creates the files matching the key names, generates user IDs based on a command line because S3 doesn't have user IDs. Sets the permissions as some default permissions and so on. I think it sets it read-only because the idea here is you're mirroring what's in S3. You don't want to change it. And then there's a copy tool that will fetch the data that's been imported and using the links that's attached as an EA. So here's a sample. Hopefully that's big enough to read. And so we wrote some new tools. Here's the LHSM command, and it has a mirror option. The import command had already been used for something else. So we mirror this bucket that's in S3, give it the destination in a file system, and the UID, and so on. And it takes a moment to run. I did that on my laptop in a virtual machine far away from S3. So it was long enough to think about maybe I need a cup of coffee, but not long enough to actually go make one. So it was a moment. I just didn't time it. So it produces a few thousand files there. It's Emacs, some ancient version of Emacs, so 3,000–4,000 files in that directory. And then there's LHSM status command, which shows recursively. This is I picked archive 100 just so it stood out. I did know you weren't supposed to use archives that high, but it did work. Then these are all release states, so these files don't have data. They're just the metadata, and they're released. There's another option to status, the -L option, which shows the HSM extended attribute that's being used for that file. And here you see they are just S3 URLs pointing to the file. So then just try restoring one manually with the command, and the status changes from released to archived. And then also you can restore dynamically by just reading the file using the file command. And again, that file is now archived and it's on the file system. So that works. That's neat. So what about a general purpose S3 archive? So that, syncing data to S3 works fine if it's kind of an export. But what if you want to keep a more dynamic, standard HSM sort of workload or use case? And so we could use the GUIDs again, use that to identify the files in the archive. And that way the archive is independent of the namespace if something is hard linked or renamed, and then you don't have to change the back end. And you store the GUIDs as extended attribute, and you can fetch that data. But you also need to archive metadata, of course, the namespace. Again, I don't want to use the database. I need to archive the metadata somehow. So one idea is to just scan the metadata in a file system, put it in marshal it in some format like JSON or whatever. It doesn't really matter. And then store that on an S3. And one option is to just scan the whole directory and put that as one key in S3. It makes it really fast to read it back because it's just one get and you get the whole directory's worth of metadata. But updates would be expensive because you have to update the entire directory if you need to support updating. Although there's one idea, you could just upload like diffs or deltas next to that key somehow, so you could download them all and then remerge them when you update them. Then another option would just be one key, similar to the original idea. If you got one key full of the metadata for that and that one file, and updates would be trivial, but of course it's a lot of back and forth to S3 to populate your file system. So there's trade-offs in both directions. Still working this out, actually. So the last idea isn't quite related necessarily to cloud in particular, but it's just an idea I had while playing with this and using GUIDs for files. And I realized that if you create a new GUID every time you archive a file after it changes, then you've got different versions of that file in the archive. So why not expose those in the file system by creating a little .hsm snap directory and creating a stub file for each version of the file that's in the archive? It kind of simulates snapshots. So here's a quick demo. Again, hopefully it's legible. The idea is you first archive a file, this important file you want to save. And archive 2 is just like a POSIX backend. And here the status -L is showing that it has a GUID instead of a URL. And it's an archived. And if you look into the HSM snap directory, you see that there's a copy of this file with a timestamp at the end of the file name. And then the status of that file, this is the one in the HSM snap directory, is released. And it has the same GUID as the original file. Now, a little bit later, this file is modified, and if you check the status of the original file, you see that it's dirty now, so we archive it again. Check the status of the file, you see it's archived, but it has a new GUID, and then in the HSM snap directory, a new file has been created with the new GUID and a new timestamp. So you got 2 versions of the file accessible now through the snap directory. Now, this isn't true snapshots, of course. It's not copy on write. You've got 2 copies in the back end, and of course, if you have a back end that's doing dedupe for you, then that makes it more interesting. But it's a feature that users would like, and this might be interesting, might be useful. So, summary, the Lustre is being used in the cloud for sure, for lots of different use cases beyond just HPC. And there's a need to manage these data sets that outlive a file system, because file systems in the cloud can be short-lived. And the idea here is really using extended attributes to use as keys or as S3 URLs and be able to fetch data from wherever they are. And then this idea of approximating snapshots in HSM cache. So before I go to questions, I'll answer Steve's question. And yes, the source is available. It's GPL. And this is prototype code. Most of it's prototype code. The S3 import is actually a feature that we support in our cloud product. So this SRPM is available in our cloud product image. There's a free version of that you can use and get the source RPM if you want to play with it. With the caveat that these other features are experimental, so like any new puppy, it's going to wet the bed and leave a stack trace on the carpet.
Well done.
And any questions?